Applications of forces, statics and particles. So we're looking at particles which are at rest, so they're not moving. The resultant force on the particle in any direction is zero, which also means the acceleration will be zero, which is obvious if the particle is at rest. Example 1, there's a particle here in the center and there are three forces acting on it, and we're looking at a top-down view, a bird's eye view. The particle remains at rest, so the resultant force in any direction will be zero. We resolve forces horizontally and vertically. Positive direction, so P cos 30 minus 4 cos 45, resultant force equals 0. And then we can rearrange to get this for P. Resolving vertically, we have 4 sine 45, P sine 30 and Q. So this time we take the upwards direction as positive, so that's an upwards force, this is upwards, this is downwards, so this one will be negative, and then we solve to get force Q, which can be rounded to 3 significant figures. So we have P and we have Q. Example 2, we have this inclined plane which is at an angle of 30 degrees to the horizontal, and our particle here is in equilibrium. It's a static particle, it is at rest. We have to work out the magnitude of force P, and we have to work out the angle alpha. The plane is smooth, so there's no friction. Resolving forces parallel to the incline and perpendicular to the incline. So we have P cos alpha, P sin alpha, 5 cos 30 and 5 sin 30, where this angle is the same as the angle of the incline. Resolving parallel to the incline and taking this as the positive direction, we have P cos alpha minus 8 minus 5 sin 30 equals 0. This is the resultant force. The particle is at rest. The resultant force in any direction will be 0. So we rearrange to get P cos alpha equals 21 over 2. This is equation 1. Resolving perpendicular to the incline, this is the positive direction. So we have P sin alpha plus 2 minus 5 cos 30 equals 0. Resultant force 0. And then we can rearrange to make P sin alpha the subject. So this is equation 2. Equation 2 divided by equation 1. So sine over cos is tan, so tan alpha is this ratio, so we can work out the angle alpha. And then using angle alpha we can work out the value of P, 10.8 newtons to 3 significant figures. For further practice, try these questions.